Hello, my name is Sonika. My roll number is 19 MCOM 81018 and I'm pursuing MCOM in St. Joseph College Autonomous Bangalore. So as part of my assignment, I have taken Operation Research for my e-content topic. So objectives. After these videos, you will be able to understand the history of research, understand the meaning and tools of operation research, understand applications of operation research, advantages of operation research, limitation of operation research, and also we'll be doing in detail the transportation models, assignment models, and network analysis. So, before learning what is operation research, first let's see the history of operation research. Operation research has gained wide popularity in the modern complex business world. Today, for complex problem in the industry, operation research tools are the solution. But is it is not surprising to learn that its roots go back to the World War II. Operation research concept was first introduced by McCloskey and United Trefton of United Kingdom during 1940. So it was there before World War II, but it had no proper name. So it was called Operation Research during that period because initially this technique was used during the World War II for solving tactical statistical problem concerning the military operations such as land defense, foods, which were scarce resources during that period. So, hence that time, England called upon teams of scientists to study these problems. So, during that period, it was a need to utilize them properly, as those problem was related to operations. So, the scientist named it as Operation Research. So, this encouraging results of the group um, attracted many exports all over the world. In very short period of time, they started innovating new and newer methods and mm, their applications. So, though search is still going on under different names like operation evaluation, system research, management science, cooperation analysis, and system analysis, etc. After World War, many industries were facing serious complex um, operational problem. The basic one was to know which method to adopt so that they can achieve the objective either by maximizing profit or minimizing the cost. Then later, during 1947, American mathematician George B. Detzing came up with a linear programming method, and later on, many new techniques and applications were developed. And in recent time, operation research are widely seen in almost all scales industry, all medium large scale industry. So uh, we saw here is that the history of operation research where it gained popularity in it gained more popularity in modern complex business world. So today the complex problem uh, in the industry uses tools of operations research, and it is not surprising to know that its roots go back to World War II. And operation research was first introduced by McCloskey and Tefton of United Kingdom. Mm, then it was the operation research name was not known before World War II, but it was there. The concept was used before also, and it was called Operation Research during World War II because it was used to uh, initially it was used to do uh, tech the techniques was used during the World War II for solving tactical uh, and strategical problem stat tactical and statistical problem. So where the land, defense, food were the scarce resources during that period. So hence the England called the team of scientists, uh, team of scientists to study this problem. During that period, it was need to utilize them properly. So as those problems were related to operations, so the scientists named it as Operation Research, and this encouraging result of the group attracted experts from all over the world. In very short period of time, the new and newer innovating methods and their applications were coming up. Uh, though the search is still going on under different names, system research, operation evaluation, cooperation analysis, management science, and system analysis, etc. Mm. After World War, many industries were facing serious issues. So, operational serious issues like operation problems. So the basic one was to know which method to adopt so that they can achieve the objective of either maximizing profit or minimizing profit. So then later on, American mathematician George B. Deming in 1947 came up with linear programming method. Uh, Then later on, all new techniques and applications were developed, and in recent time, operational research is widely seen in all medium, large scale industry. Next, we will move on to the introduction of operation research. So, operation means the problems, and research means the um, collection of information. So if we put them together, it means that um, the systematic it is the systematic and scientific method of collection of data to optimally solve the problem. So operations means problem and research means collection of information, and it means it is the systematic and scientific method of collection of data to optimally solve the problem. Here, the optimally means to solve. It optimally means um, is to do is its fullest, or to solve the problem to its best. So, Randy Robinson stresses that operation research is the application of scientific methods to improve the effectiveness of operations, decision, and management by means such as analyzing data, creating mathematical models, and proposing innovative approaches. Operation research um, by means such as analyzing data, creating mathematical models, and proposing innovative approaches. Operation research um, professionals develop scientifically based information that gives insight and guides decision making. So, Randy Robinson stresses that operation research is the application of scientific methods to improve the effectiveness of operations decision and management by means such as analyzing data, creating mathematical models, and proposing innovative approaches. Operation research professional develop scientifically based information that gives insight and guides decision making. Next, we have the tools and techniques. So, many tools and techniques of operation research are there. There are few popular tools which are constantly used in this era, which are linear programming, game theory, inventory model, transportation, network analysis, stimulation, and there are many more. So in future videos we'll be seeing transportation, network analysis, and assignment models. Next we have applications of operation research. So uh, according uh, operation research has many applications. Mainly, it is used in accounting, construction, facilitates planning, manufacturing, finance, marketing, purchasing, human resources, research, and development. So, in accounting, assigning audit teams efficiently, credit policy analysis, cash flow planning, developing standard costs, and in construction, determining of proper workforces, development of workforces, allocations of resources to projects. In facilitates planning, factory locations and size decision, estimation of number of facilities required, hospital planning. In manufacturing, inventory control, marketing balance projection, production scheduling. Finance, investment analysis, portfolio analysis, dividend policy making. And in marketing, advertising budget allocation, product introduction timing, selection of product mix. And in purchasing, optimal buying, reordering, material transfer. In human resources, personal planning, recruitment of employees, skill balancing. And in research and development, we have R&D projects control, R&D budgets allocation, planning of product introduction. So the operation research can be applied in all these fields. So accounting, construction, facilitate planning, manufacturing, finance, marketing, purchasing, human resources, research and development. And the list does not end here. There are many other fields where operation research can be applied. So next we have the advantages of operation research. First is effective decision. Operation research help to make it easier and faster for decision making for managers. So this was the number of alternative. It lets manager determine the cost and consequences of all alternative. Uh, Then it helps to make the decision which we have made more successful. So we saw is effective decision, where the operation research helps to make it easier and faster decision to make it for managers, and the managers determines the costs and consequences of all the alternative, and it helps in making the decision which we have made more successful. Then the second advantages is better coordination and control. So operation research helps to organize all the organization's decision. It coordinates all the decision made by the different management level and the organization's various department. So, operation research helps the organizations to organize all the organization decision, and it coordinates all the decision made by different levels of management and the departments, various departments. The third advantages is it improves the productivity. So, operational research aims to increase the efficiency of the decision on the opinion which they have made. So, it helps in location and size of factories, warehouses, etc. It helps in the management of inventory, and it also helps in the planning and control of production, and also assist in the preparation of manpower. So we saw three advantages: effective decision, better coordination and control, improve productivity. Better decision, it helps in making better decision and make the decision which we have made more successful, and it helps in easier and faster decision for managers. Better coordination and control, it helps in organizing all the organization decision, and it also helps in coordinating the decision which are made by different levels of management and also the various department. Then improves productivity, so it increases the efficiency of the organization. It helps in increasing the productivity, and also making decision, also deciding on the opinion, like location and size of factories, warehouse, etc. And it also helps in planning and controlling of production, and also in assisting in the manpower preparation. Then we have limitations of operation research. The first limitation is distance between OR specialist and manager. So the work of operation researcher needs a mathematician or statistical uh, who may not be knowledgeable of business issue. Likewise, a director is unable to grasp the complex nature of operation analysis. So there is therefore a major difference between the two jobs. Um, Distance between operation research specialist and manager. Here, the operation research needs a special mathematician and statistician who may not be knowledgeable about the business issue. Similarly, the director may not be able to grasp the operations analysis, which is complex in nature. So, therefore, there is many difference between the two jobs. The second one is magnitude of calculation. So, the goal of the operation research is to find the right solution, taking into account all the variables. And these variables are enormous in the modern world, and expressing them in quantitative models and creating a relationship between them involves a lot of calculation that can only be done by machines, a lot of work which can only be done by machines. So the magnitude of calculations is the finding the right solution is very difficult. It takes all the variables around it. It considers all the variables around it. Then the variables in this modern world are too many, and expressing them into quantitative form and creating relationship between involves lot of modern calculation, various calculation that can only be done by machines. Then the third limitation we have is money and time cost. So the basic data are subject to frequent changes, and it is very expensive to incorporate these changes into the operational research models. However, at present, a fairly good solution may be more desirable than a perfect research solution for operations available in the future or after a while. So money and time cost means the data subjects to frequent changes, and it is very expensive to make those changes into the operation research model frequently. So in present scenario, a fairly good solution may be more preferable than a perfect solution for operation available which are in future or after a while. Then the fourth disadvantage limitation is non-quantifiable factors. So if all variables related to problem can be quantifiable, only then otherwise operation research does not have a solution. The non-quantifiable factors are not included in the OR models. So OR importantly, OR do not take emotional or qualitative factors into account. So if all variable related to problem uh, can be quantified, only then otherwise operation research do not have solution for all non-quantifiable factors. Only quantifiable factors can be solved with operation research. And importantly, OR models do not take emotional or qualitative factors into account. The fifth limitation is implementation. It should be applied after decision has been made. The execution of decision is a difficult task. This role must be taken into account the complexities of human relation and actions, uh, and at times only psychological factors. So the application, so the decision should be made, and then the application should happen. The execution of the decision which we have made is a difficult task. So this role must take into account the complexities of the human relations, and act upon them. And then only psychological factors can be seen at times. So we learned is the history of operation research, where we saw that the concept was first introduced by McCloskey and Tefton of United Kingdom, and it gained wide popularity in modern business world. Then the name of Operation Research came into after Second World War, where the purpose was of solving tactical and strategic problem which were concerning the military operations like land defense, food, which were scarce resources. Then Operation Research. After World War, many industries were facing serious complex execution problem, where the basic one was to know the method adopted so that they can achieve the objective of either maximizing the profit or minimizing the cost. And then in 1947, George B. Detzing, an American mathematician, came up with linear programming method, and later on many mm, new techniques and its applications were introduced. And in recent time, operation research is widely used in almost all the mediums large scale industry. Then we moved on to introduction of operation research, where operation means the problem and research means the collection of information. uh, then in the when we combine it, it means that 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 it is the systematic and scientific method of collection of data to optimally solve the problem. Then we also saw the definition by Randy Robinson. He said that operation research is the application of scientific methods to improve the effectiveness of operations decision and management by means such as analyzing data, creating mathematical models, and proposing innovative approaches. Operation research professionals develop scientifically based information that gives insight and guides decision making. Uh, then we went on to see the tools and techniques. There are many tools which are used in this modern world, modern scenario, but the popular ones are linear programming, game theory, inventory model, transportation, network analysis, and stimulation. So in future videos, we'll be learning about transportation, network analysis, and assignment model. Then we have applications of operation research, where we saw it is applicable in many areas. A few of them are accounting, construction, facilities planning, manufacturing, finance, marketing, purchasing, human resources, research and development. So in accounting, there are many which is assigning audits team effectively, credit policy analysis, cash flow planning, developing standard cost. Then in construction, determination of proper workforce, employment of workforce, uh, allocation of resources to projects, factory location and size decision in facilitates planning. Similarly, likewise in manufacturing, finance, marketing, purchasing, and human resources and research development, there are many areas where operation research is applicable under these, and there are many more. It is not limited to these areas. Then we went on to see the advantages of operation research, which was effective decision, where we saw that it helps to make the easier and faster decision for managers, and it also helps managers to determine the cost and consequences of all alternatives, and it also make the decision more successful. Then the second advantages we saw is better coordination and control. So operation research helps in the all the organization to have better control and better coordination. It helps in making all the decision which are made by different management levels and organizations of various departments to coordinate with them. And the third advantages is improves the productivity. So operation research aims to increase the efficiency. It helps to decide the options, locations, and size of factories, warehouse, and it also helps in planning and controlling of production. And it also helps in assisting the preparation of manpower. Then we went on to see the limitation of operation research. The first is distance between OR specialist and manager. So OR specialist will be the specialist in uh, mathematics or statistics, who may not be knowledgeable about the business issue. Similarly, director is unable to um, grasp the difficult the complex nature of operations analysis. So there is a major gap between them, and there is this different between their jobs. Then magnitude of calculations, the second limitation. So operation research takes all the variables which are available uh, to consideration. So these variables are too many, enormous in the modern world, and expressing them into quantitative model is very difficult, which is creating relationship between them, involving the various calculations that only machines can be done that can be done by only machines. So the third limitation is money and time costs, which is uh, that it is very expensive to incorporate the changes in operational research models. So, however, a fairly good solution may be more likely preferable than a perfect research solution for operations available in the future. Then the fourth limitation is non-quantifiable factors. So all the variables related problem can be quantifiable, but operation research does not have a solution. So the only way the quantifiable problems can be solved using operation research. Non-quantifiable factors are not included in operation research models. So operation research do not take uh, qualitative or emotional factors into consideration. Then the implementation. So uh, the application should be done after the decision is made. Then the but but the execution of it is difficult. It's a difficult task. So um, the role is to take into consideration the complexities of human relations and act upon them, but at times only psychological factors can be considered. Now we will move on to see the next model, which is transportation. So, transportation problem is a particular type of linear programming problem, that is LPP, in which goods are transported from a set of source to a set of destination according to the supply and demand of the source and destination respectively, in such a way that the overall cost of transportation is reduced. So, transportation problem is a particular type of LPP, linear programming program, which has the uh, where the goods are transported from a set of source to the set of destination. So, according to the demand and supply of sources and destination, respectively, in such a way that the cost of overall transportation is reduced. Then we move on to the next, the problem, which we will try solving is using a simplex method. So the problem goes on like this. Suppose a manufacturing company owns three factories, sources that is, and distribute his products to five different retail agencies, destinations. The following table shows the capacities of the three factories, the the quantity of products required by the various retail agency, and the cost of shipment one unit of the product from each of the three factories to each of the five retail agency. So we have the problem here. Here what it says that in above table, the transportation table, it provides the basic information regarding the transportation problem. The quantities inside the table are known as transportation cost per unit of product. So the capacity of factories is one to factory capacities of factories 1 to 3 is factory 1 to 3 is 50, 100, and 150 respectively. And the requirement of retail agency 1, 2, 3, 4, 5 is 100, 60, 50, 50, and 40 respectively. So in this case, the transportation cost of one unit is From factory 1 to a retail agency 1, it is 1. Then factory 1 to retail agency 2, the cost is 9, transportation cost. Then factory 1 to retail agency 3 is the transportation cost is 13. Similarly, for factory 2 to retail agency 4 is 20. And from factory 3 to retail agency 5 is 26. So it goes on like this. Then next we have is a transportation problem can be formulated as a linear programming problem, that is using variable with two subscript, as we are solving this question with simplex method. So we have to uh, assume here. So let's assume that x11 sorry, x11, that is 11, amount to be transported from factory 1 to retail agency 1. X11 is amount to be transported from factory 1 to retail agency 1. That is X11. We assume that amount cost for transporting from factory 1 to retail agency 1. Similarly, X12 is the amount to be transported from factory 1 to retail agency 2. That is X12 is the amount to be transported from factory 1 to retail agency 2. Then it goes on like this: 1 x13 for amount cost which is used for transporting factory 1 to factory 3, then factory 1 to factory 4, it will be x14, then factory 1 to factory 5, it will be x15. Then in second row, second factory, factory 2 to factory 3, x factory 3, x2 3, then factory 2 to factory 5, x2 5. Then from factory 3 to factory retail agency 2, it will be x3 2. Then factory 3 to retail agency 5, it will be x35. X35 amount to be transported from factory 3 to retail agency 5. Then let the transportation cost per unit be represented by C11, C12 and so on. That is C11 equals to 1, then C12 equals to 9, the transportation cost for for the factory 1 to reach to factory retail agency 1 2 3 4 5. So it will be for 1 to 1 it will be, so which will be C11, then C12 as 9, the transportation cost, then C13 as 13 and so on. Let the capacities of the three factories be represented by A1 is equals to 50, A2 is equals to 100 and A3 factory 3 is equals to 150, and let the requirement of the retail agencies uh, uh, are B1 which is 100, B2 which is 60 and B3 which is 50, B4 which is 50 again and B5 which is 40. Thus the problem can be formulated as minimize C11 into 11 x11, that is the x11 is the transportation amount to be transported and C11 is the cost involved in transporting. So minimizing C11 x11 plus C12 x12 plus C13 x13 Similarly, it goes on till C35, X35. Then subject to X11 plus X12 plus X13 plus X14 plus X15 is equals to A1, which is A1. Then X21 plus A1 is 50 plus X21 plus X22 plus X23 plus X24 plus X25 is equals to A2. X21, X22, X23, X24, X25 is equals to A2, which is 100. Then we have X31, X32, X33, X34, X35 is equals to A3, which is X31, X32, X33, X34, X35, which is equals to A3, which is 150. Then X11 plus X21 plus X31 is equals to B1, which is X11, X21, X31, which is equals to B1, which is 100. Then we have X12 plus X22 plus X32 is equals to B2. That is X12, X22, X33, X32, which is equals to B2, which is 60. Then it is X13 plus X23 plus X33 is which is equals to B3, which means X13, X23, X33, which is equals to B3, which is 50. Then we have X14, X24, X34, which is equals to B4. X14, X24, X34, which is equals to 50. Then we have X15 plus X25 plus X35, which is equals to B5, which is 40. Then where X11, X12, that is X11, X12, X13, X14, X15, X16 to X35, it is greater than or equals to 0. Thus, the problem has 8 constraints and 15 variables. So, it is not possible to solve such a problem using simplex method. So, this is the reason why we need the special procedure to solve transportation problem. There are various varieties of procedure which are described, uh, uh, which are there to solve, which are transportation algorithms, which are northwest corner method, least cost method, and Vogel's approximation method, which is the first step of solving the transportation problem. The three methods are northwest corner method, least cost method, and Vogel's approximation method. The three methods are different in nature, uh, and when we solve, the Vogel's approximation method gives the lowest transportation cost, and northwest corner method gives the highest transportation cost. So, but the Vogel's approximation method is mostly used in questions. Then after using these methods to determine the basic feasible solution, after basic feasible solution is found out, then the optimal solution is also be found, that which can be found by the MODI method, which is modified distribution method, or also known as UV method, where the UV of the table is found out and then the opportunity cost is find out. So when the opportunity costs are all positive, that time the solution is called the optimal solution. So we saw that the transportation model, it means that transportation means that it is a problem where it is a particular type of linear programming problem where the uh, transportation from a set of source to a set of destination happens according to the supply and demand of the source and destination uh, respectively, in such a way that overall transportation cost is reduced. Then we went on to see the first problem where we had three factories and five destinations, which were retail agency, and uh, the capacity of factory 1 is 50 and factory 2 is 100 and factory 3 is 150, where we had the transportation cost for factory 1 to retail to reach to retail agency 1 is 1, and transportation cost for factory 1 to reach retail agency 2 is 9, and transportation cost for factory 1 to reach retail agency 3 is 13, and so on. For 1 to reach 4 it is 36, and from F1, which is factory, and retail agency can be known as destination also. So we can write it as retail agency 1 as D1, retail agency 2 as D2, retail agency 3 as D3, and retail agency 4 as D4, and retail agency 5 as D5. Similarly, here the factories can be written as factory 1, factory 2, and factory 3. So F1 to D4, it takes 36 for transportation cost. F1 to D5, it takes 51 for transportation cost. And the capacity for factory 1 is only 50. Then factory 2 to D1 is 24. Then factory 2 to D2 is 12. Factory 3 2 to destination 3 D4 D3 is 16. Factory 2 to D4 is 20. Factory 2 to D5 is 1. Then similarly, factory 3 to D1 is 14, factory 2 to D3, D2 is 33, factory 3 to D3 is 1, factory 3 to D4 is 23, factory 3 to D5 is 26, and capacity of factory 1 is 50, factory 2 is 100, factory 3 is 150, and requirement of retail agency 1 is 100, retail agency 2 is 60, retail agency 3 is 50, retail agency 4 is 50, retail agency 5 is 40. So in the above transportation problem, it provides the basic information regarding the transportation problem, where we already saw that the capacity is of factory 1, factory 2, factory 3 is 50, 100 and 150, and requirement is 100, 60, 50, 50, 40 for retail agency 1, 2, 3, 4, 5 respectively. So in this case, the transportation cost for 1 unit. So from factory 1 to factory retail agency 1 is 1, and it goes on. So like till factory 3 to reach retail agency 5, that is 26. Then a transportation problem can be formulated in linear programming problem using variables with two subscripts, where the x11 will be the amount which should be transported from factory 1 to retail agency 1, and x12 will be the amount to be transported from factory 1 to retail agency 2, and x13 will be the amount which has to be x13 will be the amount which has to be transported from factory 1 to factory 3. Then amount x14 will be the amount which has to be transported from factory 1 to factory 4, and so on the till x35, which is the amount to be transported from factory 3 to factory 5. Then um, let the transportation cost per unit represented by C11, C12, C13, C14 till C35, that is C11 equals to 1, C12 equals to 9, C13 equals to 13, C14 equals to 36, C15 equals to 51, and so on till C35, which is equals to 26. Then let the capacity of the three factories be represented by A1, which is equals to 50, A2, factory 2 is represented by A2, which is equals to 100, factory 3 is represented by A3, which is equals to 150. Similarly, let the requirement of the retail agencies are B1, B2, B3, B4, and B5, which is retail agency 1 is assumed as B1, which is 100. Retail agency 2 is assumed as B2, which is 60. Retail agency B3 is assumed as B3, which is 50. Retail agency 4 is assumed as B4, which is 50. Retail agency 5 is assumed as B5, which is 40. Then the problem can be formulated as uh, minimize C11 X11, which is C11 is the cost of transporting, and X11 is the amount which has to be transported. The products, the amount of products which has to be transported. So C11 X11 plus C12 X12 plus C13 X13 plus C14 X14, so on to C35 X35. Then subject to x11 plus x12 plus x13 plus x14 plus x15, which is equals to a1, which is 50, x11 x12 x13 x14 x15, which is equals to a1. Then we have x1 x21 x22 x23 x24 x25, which is equals to a2. Then we have x31 x32 x33 x34 plus x35, which is equals to a3. Then we have x11 x21 x31, which is equals to b1, the horizontal one. x11 x21 x31, which is equals to b1. Then we have x12 x22 x33, which is equals to b2. Then we have it is x32. Then we have x13 x23 x33, which is equals to b3. Then we have x14 x24 x34, which is equals to b4. Then x15 x25 x35, which is equals to b5, where x11 x12 x13 x14, so on till x35, which should be greater than or equals to 0. So the problem has 8 constraints and 15 variables. So it is not possible to solve such a problem using simplex method. So this is the special reason where we the require to solve the special um, method to solve the transportation problem, uh, where we have three methods, three algorithms in transportation, which are northwest corner method, least cost method, and Vogel's approximation method. These are the three basic methods which we which we solve which we solve using transportation using these three methods, where northwest corner method gives the highest transportation cost and Vogel's approximation methods gives the lowest transportation cost. So that's why Vogel's approximation method is uh, used mostly in solving the problems. Then we have least cost method, which comes in middle. So the least cost method, after solving least cost method, the transportation cost which we get is higher than the lower than the northwest corner method, but it is higher than the Vogel's approximation method. After using these three methods, we get basic feasible solution. So the question doesn't end there. We have to solve the optimal solution also. We have to get the optimal solution also. So to get the optimal solution, the MODI method, which is modified distribution method, or UV method, is used, where the u and v values of the table is found out, and mm, then the opportunity cost is found out, where the opportunity cost should be positive for all allocations. If it comes positive, that means the solution is optimal, and if it does not comes positive, then we go ahead with the iteration or revision. Now, steps in solving northwest corner method is, first step is to identify the northwest corner cell. Then the allocation should be done there. So first, destination and sorry, demand and supply columns had to be seen, where the maximum allocation can be done. That should be allocated, which means if demand we have 40 and supply it is 30, so maximum allocation can be done is 30, because the supply is only 30, although demand is 40, but supply can be done is 30, so maximum allocation can be done is 30. Then after allocating the north west corner cell, then we have to see which one has become zero, the supply or the demand. Here, as we took the supply as 30 and demand as 40, so we allocated 30. That means the supply cell became 30. So that row should be cancelled out. Then after that, we move on to identify the next northwest column. Then after allocating similarly how we did in the first step, we have to find out the zero in supply or demand cells. Whichever it has become zero, that column or row is fully cancelled out, and then again it is moved on to see the next northwest corner cell, and again the allocation is done. After getting all the allocations, we have to check if uh, it uh, it is non-degenerate or not, which means m plus n minus 1 should be equals to the total number of allocations, which means m is the total number of factories and n is the total number of destination. So m plus n minus 1 should be equals to the total number of allocations. Then after that, the allocations should be multiplied with the allocated cells cost, and then we get the total transportation cost by using northwest corner method. So the steps involving in northwest corner method is, first we have to identify the northwest corner cell. Then we have to see the which is the amount which can be done maximum allocation. So the demand and supply is seen, where the example I gave is where 30 is the supply and 50 is the demand. So 40 is the demand. So 30 only can be allocated maximum, as only 30 supply can be done. However, 40 is the demand. Then the supply cell became 0, so that row is cancelled out. Similarly, next again we move on to the finding the northwest corner cell, and again as the allocation the step did first step we followed, similarly in the second cell also the allocation should be allocated, and similarly till we reach the bottom right corner, when all the allocations is done, where when all supply and demand becomes 0, then the non-degeneracy should be checked, where m plus n minus should be equal to n minus 1 should be equal to the total number of allocations. And after checking that if it is non-degenerate, then we go ahead with multiplying the allocations with the allocated cells cost, and then after that we get the total transportation cost uh, by using northwest corner method.